Okay, sorry about that. So, all right.
Yeah.
So we just did some introductions, and here is our next slide. This is our contact information. So feel free to get a hold of us.
So this recording this webinar will be recorded and we will post it on YouTube in the near future. So if anyone you think that'll be interested, just feel free to share the YouTube video, for those who can't make it. And so why home hardening matters. So our first webinar was about rooftop fire sprinklers. And then so this one we did a few case studies. We drove around the Palisade and Altadena area and noticed there are a few houses that were not burned by the fire. And one common theme was the material that protected the house. And so we wanted to do a case study on just concrete material for residential building projects. And oftentimes we feel like concrete is cold, it's ugly. There are some pros and cons to it, and we would just like to share with you what we have discovered.
Yeah, and so I guess another reason too is because well, wildfires are, becoming more and more frequent. So here's just some statistics on wildfires in California. And you can see that almost every year we have, wildfires in California. And let's see, so, you know, it is becoming our kind of like daily life, yet, at the same time, we are always kind of, being kind of unprepared and, surprised by it. So, and it also does seem like, we need to strengthen our home, more than we had in the past because the fire code really has not had, very many changes. In the last 10 years. So, and as Christina said, concrete is definitely one of the best materials for fire resistance. So the building code categorizes building types based on fire resistance, and concrete and steel buildings are categorized as the most fire resistant. So here's like a table from the building code. There's type 1, type 2, type 3, type 4, type 5 buildings. And these types basically, explain what the construction type is. And these are categorized based on, I guess, like the construction material. Type 5 is wood framed buildings. And so you can see that this is way at the end. And most of the houses are constructed using type 5, and type 1 is concrete and steel. So that's the most, fireproof building material out there. So, so that's why we are focusing today on the concrete. How do fires start? So there's the fire triangle. You guys probably know that. So the fire needs three things. It needs heat, fuel, and oxygen. So the heat could be an ignition source. This could be a spark, a flame, high temperature from friction, chemical reaction, lightning bolt, or electrical fire. Fuel is any combustible material, and it also needs oxygen. So the fuel can be anything. It can be dust, it can be wood, paper, fabric, any of these things. So if you remove any of these items, then you can stop the fire. And Christina had, I guess, like a past client in
Um,
Altadena.
well,
You
no,
want to talk about it?
yeah, it wasn't a client. So I was just watching, a video on Instagram of a person who was documenting the fire uh, in Palisade area around his home. And so he noticed that, and he decided to stay behind to try to save his house. And he noticed that as the fire started at far away, it was a smoke that came first to his neighborhood. And he noted that as the smoke enter into somebody's attic, eventually that attic starts burning. And as smoke continues to travel to the next attic or next house, that attic will start burning. And so that video was very hard to watch just because, he was showing his desperation and figuring out how to stop the smoke from coming, which is technically impossible. Eventually the smoke did come to his house. His attic started burning, and they had firemen in his house trying to put out a fire from underneath the attic. And so, yeah, usually we talk about ember that starts the fire, but just from that video, just having the heat and fuel, there's usually tons of stuff inside the attic that probably do become combustible materials, such as the insulation, and there's oxygen. So even
Mhm.
with that type of heat, it's possible that,
Mhm.
just with that can start the fire in the
Right.
case
So
of
yeah, the smoke itself, I guess, actually carries combustible materials, which is shocking to me because we are always talking about how to stop the embers from getting into the attic. But actually, the smoke itself can, I guess, like cause fire. So that is, really new information to me. So concrete's fire resistance properties. So let's talk about concrete as a material. Why is it like, so, fire resistant? It is a non-combustible material, meaning that it doesn't catch on fire. It has high thermal mass and it has structural stability under high temperature. And then we'll also talk about protection of reinforcement. So let's see. So high thermal mass, what does that mean? Basically, what it means is that concrete has this ability when there is fire on the outside, the inside will stay cool. So it doesn't transmit the heat very easily. So other materials like metal is quite the opposite. So if the metal gets in contact with heat, it quickly transmits the heat and you can get burnt. Why this is important is because a lot of times the outside might be okay, but then because of the heat, a lot of the interior can be damaged. So this is important ability for concrete. Concrete is also structurally stable under high heat. So it can withstand about like 1,100 degrees Fahrenheit, which is, pretty high. And we could compare this to maybe other materials. So wood will burn at like around 400 degrees to 600 degrees Fahrenheit. Metal will start to deform at about 500 degrees to 700 degrees Fahrenheit. Vinyl will start to deform at like, 140 degrees Fahrenheit. And just so you know, wildfire can, reach temperatures ranging from 1,472 degrees Fahrenheit to 2,192 degrees Fahrenheit. So, so even, you could kind of see that like, the heat that comes from a wildfire is pretty intense that and so that even with concrete, the structural stability might not be enough. So that's something to keep in mind. So what does that mean to have protection of reinforcement? So concrete usually has metal structure inside the concrete. It'll have like rebars, it'll have beams, things like that. So a lot of times when the steel beam is just exposed by itself, or if it's wrapped in wood, then it doesn't have as much protection as if it were to be, wrapped within, a concrete column or, beam. Um, so the concrete will keep the metal from deforming. Um, So here are some examples of concrete-based fire-resistant materials. So when you think about concrete houses, a lot of times I think people just think about these big, huge concrete walls and concrete floors. And it doesn't have to be like that. So here are some of the, concrete fire-resistant materials. There's things like the ICF, fiber cement boards, CMU, cement tile roofs. I think concrete is pretty prevalent, and I think a lot of people don't really realize like how much concrete there is in our buildings already. So this is an ICF building. So you can see this gentleman, putting this form, like building blocks, like Lego blocks on, and stacking them together. So these are insulation, and they're clipped together using this plastic in the middle. And after they put the form together, they would pour the concrete all at once and create this concrete wall. The insulation on the sides, they don't go away, so they're there permanently. So the insulation will provide insulation to the building. So this is a pretty innovative technique. It makes construction a lot easier. Um, I think ICF is frequently used in foundation walls. Sometimes they're also used for like the whole house. Let's see. So here are some more examples of the ICF. This is like a whole house that's being built using ICF. The only like downside for using ICF is that I think a lot of times people have to put the conduits, electrical and plumbing inside the concrete wall. So, accessing them, if you have to like modify them or fix them, you have to, it's a lot more work to try to, I guess, move them. So this is an example of CMU wall. So this technology, CMU, is kind of it's used frequently in other parts of the world. It's generally like I think like all the especially like in South America, people are really interested in building so that their building will last forever. Whereas like I think places like North America, we are more interested in what the new trend is. So we're not as interested in having buildings last forever. So this kind of building technique is just not that I guess common over here. So I think a lot of times like people are concerned about CMU buildings because they feel they're worried about electrical outlets and plumbing fixtures and having to drill inside the CMU block to I guess like have the conduits run through it. Usually so I get that kind of comment a lot. But when we're talking about CMU, but usually with CMU you would put some kind of finish on the outside. So this one they're putting stucco on the outside. You could put fiber cement boards. You could put rammed earth. You can put like anything on the outside. And then on the inside, usually there's another wall, like another 2x4 wall that would have the, outlets and lights and things like that, plumbing fixtures. So yeah, so there's no worry to like, put having to put in the outlets directly into the concrete. Here are some examples of what fiber cement boards are. So this is like a panel, and so this is fiber cement boards are lightweight, they're fire resistant. It's a good alternative to wood siding. It doesn't rot. There's no worry of termites or insects, eating them. And so this one is a very modern building, and usually this fiber cement panel usually has some kind of rain screen behind the panel. So there's metal battens that run vertically behind these panels. But a lot of people are more familiar with this type. So these look like wood siding, but it's actually fiber cement boards. Um, and then we also have cement tile roof. I think a lot of people already know this, construction type. So cement tile roofs, these are good alternatives to things like wood shake or slate. So these fiber cement tiles, they come in all sorts of shapes, sizes, colors, and some of them do come with like wood texture to make it look more like wood shake. So are concrete affordable? Yeah, a lot of people are kind of worried about like, oh, concrete is like so expensive, one can't afford that. Well, let's take a look. So a lot of this information was taken from RS means data. And so 6-inch CMU wall is in this area, in LA area, they could be about $21.42 a square foot. Whereas like if you compare it to a 2x4 wall, which is about $5.49 per square foot. Concrete tile roof can be about $529 a square foot, whereas clay tile roof is $733 a square foot. And Class A asphalt shingle roof is $250.48 a square foot. So, all of these concrete tile, clay tile, Class A asphalt shingle roof are Class A. So, meaning that the fire code, they meet the fire code minimum. Fiber cement siding that's 6-inch exposure is about $8.60 per square foot. And these are all install cost. So these are taking a look at the material and also labor to install it. And then the wood siding that's 6 inches cedar will be about $5.37 per square foot. And so when you are talking about how much do these things cost, you also have to take into consideration life cycle cost. So although, see concrete things, these materials might be, more expensive up front. If you take a look at like wood siding, wood siding has to have a lot of maintenance. You have to, paint it every now and then you also have to, they are prone to termites and rot. And so you would have to, replace some of the wood siding itself. Whereas fiber cement, boards don't have that kind of issues. So they do last, longer with, less maintenance. Fiber cement boards do warp from time to time. So That is something that, you do have to take into consideration. But so, the concrete materials do last longer, and they have, certain properties that are advantageous to, certain situations. Like they have high thermal mass and they are more fire resistant. So if you design your house nicely using these features, then, you can have like a better quality house. So let's go into some of the case studies. So Christina and I, visited some of the burnt sites, and this is one of her friend's house in Altadena. Christina, you want to talk about this house?
Sure. So this house was built back in 1948. And first of all, we thought it was very interesting that, you know, back in that time, somebody would already thought of building a house out of CMU blocks. Um, and so this house, both the interior walls and the exterior walls are built with CMU blocks. And unfortunately, the windows are also the original steel framing, single pane. They still have the old um, codes requirements regarding floor ventilation and eave ventilation. The roof, you can see is wood framing. So can you scroll to the next slide, please?
Yeah.
And so unfortunately, the roof did not withstand a fire. So it collapsed down and the fire got inside the house from above with the roof collapsing. But as you can see here, the interior walls are also with the CMU blocks. Um, and
Like right here.
yeah, and it's interestingly, the conduits for electrical are actually inside the blocks. And the light switch, you can see the picture on the left, the light switch actually installed onto the CMU. And my friend, she's actually considering looking into reusing the walls, even though, she actually hated it because she's an interior designer. She loves to remodel homes, but for this house, she really couldn't do anything to
Yeah.
make it the way that she wants. But at least she knows that we know that walls stayed, even after this fire.
Yeah, and so this, like, you could kind of see, like, this window here was like the original steel windows, and it was single pane windows, right? And so we're thinking that one of the reasons why, it caught on fire was probably because of the roof. And so, I mean, this house was built in the 50s, right? And so a lot of the things look like they're original. Like these windows were original single pane steel windows. We did find, vents up here. In the roof, there are vents down here and oh yeah, down here. And they didn't look like they were the WUI approved vents with a tiny, tiny mesh. So we're not sure, when's the last time this roof also got replaced either. So we're not sure if it's Class A roof or, any other kind of roof.
Yeah, with this picture, we can tell them, the houses in the neighbors are burned down to ashes, but her house managed to survive, at least most of it. Yeah.
So here's a house in Pacific Palisades. We actually found out about this house because of some news recordings, and it was one of the houses that survived in Pacific Palisades. It was designed by an architect, Michael Kovac, and his wife, and there's a lot of innovative technologies used on this house. For example, this is fiber cement panels used up here, and they also used ICF. Everything outside on the exterior is non-combustible, meaning that they don't have materials that would catch on fire. And this image right here shows its next door neighbor. The next door neighbor is over here. You can see like, the devastation over here. There's almost like nothing left on, on the neighbor's side. And You can see that this bamboo, I think that even the landscaping was fire-wise landscaping. And the bamboo got scorched, but the house itself, survived. They were really kind enough. When we drove up here, we didn't make an appointment or anything. They were kind enough to let us in and, talk to us a little bit about their house. This was an image inside their house. They showed, their construction sequencing, and they let us take pictures of some of the things inside. You can see the ICF, being used for the lower floors. So I think this is like a three-story house, maybe 2 or 3 stories house. So this is the top floor, and then there's floors beneath the earth here. One thing that to note was that even though this house survived, I guess like they still could not like move back in, and they're anticipating that they will be out of the house for at least a year. Inside the house, everything survived, and we couldn't find anything that really was even like damaged or um, outside or inside the house, but there was a lot of smoke inside the house. So they would probably have to do, a lot of like smoke mitigation in order to be able to move back in. And this shows you, this is a house, and everything around the house, got burnt down. This is another house just down the street from that original house. And so this one was another house that was built using ICF. So Michael told us, about this house and told us that we should go take a look at it. This is an image that was taken before the fire. All of its neighbors and everything is intact. But you can see this aerial picture of this house and how, everything is totally intact. But look at the devastation that happened all throughout, its neighbors. Um, so this is another house just across the street from, house number 3. So this house also survived. I think most of these houses look like they were even house number 3 and house number 2, they were all relatively new. They were built within the last 10 years. This house in particular, I think the only thing that was original, I think, is the garage, and everything else was rebuilt in 2007. We're not really sure what the construction is, what the framing is, if it's wood, if it's steel frame, or, if it's concrete. But it does look like it's a stucco outside. Um, when you come close to it, we saw that this also had bamboo, I guess like as part of their landscape. And um, the window here, it's a double pane window, and one of the panes actually broke. So you could kind of see like the intensity of the fire that was adjacent to, I guess, like this house. This is the other side yard of the house, and it's completely, almost completely intact. And some of the, I guess, like landscape actually got burnt in the front yard here. But that's pretty incredible to see. Um, so this is the house that we were taking a look at. This is a side yard here that was completely intact, and then you can see how both of its neighbors burnt down. This is an interesting case study in Altadena. So this is a historical home. It's the Zane Grey Estates. This was the first fire-wise home that was built in Altadena, and it unfortunately, got burnt down with the last Eaton fire. But let's see. Here is just a little website about the house. It was actually built in 1907, and it was built entirely of reinforced concrete. Um, and here are the images of the house. Okay, yeah.
Yeah,
So
so with this house, what we think happened, because it is built back in 1907, the aerial image from Google Maps shows also a huge hole on the roof. So we think probably the fire also got to the roof, perhaps got into the attic through the vents and then collapsed the roof down, um, which destroyed the house from the inside. Similar to the other CMU house that my friend has in the beginning of the first house in our case study.
hmm I
Yeah.
think that both of the houses, this house and also Christina's friend's house, even though they did have concrete walls, you could see like for this house, the windows are even burnt down. So these probably were wood windows, and so they didn't quite survive. And so yeah, I think that leads us to our next webinar topic, which is, I guess, 6 ways of fire code compliance. So this is going to be in on April 2nd. We're always doing our webinars on first Wednesday of the month at 11 a.m. And we are going to take a look at, some of these fire code compliant measures. So we'll talk about Class A roof, the events, and fenestrations that are fireproof.
Okay. So Tom has a question. I'll just read it from the chat. It says typically fire building code require up to 1 hour fire resistance for specific materials or finished structures. Large fires involving multiple structures and or high winds can threaten properties for longer times. How do you balance cost versus risk abatement?
Well, so I think that that's definitely a personal choice for sure. It's also not just personal choice. I do highly recommend taking a look at your insurance. And so I we're going to talk about these code compliance, fire code compliance measures, and these are the things that the insurance is going to take a look at. So they if you it's sort of kind of like a checklist, and if you the more items that you check off on your house, these different measures, the more discount you'll get from your insurance. And so I think the how the insurance works or how much discount you get is kind of nebulous. Like I don't really know how it works, but you do get, it does seem like you do definitely get like a discount. So those are some of the things that you could take a look at regarding that.
Great.
But other than that, I think that it is definitely a personal choice. Like, how much fire mitigation do you want to do? How much do especially now that, you may or may not be able to have fire insurance in the future, maybe it might be up to you to really, make sure that your house is protected.
Yeah, Laura just sent a link in the chat from the California Department of Insurance regarding wildfires. So you guys can just click on that and down and take a look through the resources. Thank you, Laura. There's also other concrete systems that Reiko and I have been looking at that we have not shared on here just because they are less common. One of them that you said was Gigacrete. Um, and
Yeah. So
yeah, and there's also different types of boards, which, I feel like it seems like after this fire, there's going to be more and more manufacturers and creative ideas of using concrete to protect the home. And then these ones that we shared here are more that's been around for a while, that's been more commonly used. Um, so yeah, we're just, excited and also looking forward to see, what other things that the construction companies and materials going to come up with, to help strengthen the house and give us options too, how to design, more traditional style homes instead of, the modern looking boxy homes that we see that's usually done with concrete.
mhm. Yeah, so yeah, definitely. I think a lot of people have an aversion to the idea of, using concrete. But it doesn't always have to be, this like very big, huge monolithic, cold industrial building. Definitely, concrete is like, in our daily life. So, and it has been around for, a long time.
Yeah.
Gigacrete, I guess, they manufacture ICF, as well as, like a new metal frame technology where, we could do a webinar on something like that, like an innovative technology in the future.
Yeah.
Yeah.
Great. Any one of you have questions, you can just come off mute. Yeah, if you have any comments or questions.
Yeah, and we'd be happy to share this, webinar in the future as well, like on YouTube. I guess if we don't have any more questions, I think we're done, right, Christina?
Yeah, thank you. Yeah, I think so. Thank you guys for coming.
Yeah, thank you.
All right. Have a great day.
Bye.